Welcome to Two Projects. In this video, we are going to explain the project Attentional Multi-Channel Convolution with Bidirectional LSTM Cell toward Hate Speech Prediction. Introduction. Online social networks, that is OSNs, have become integral to modern communication, serving as platforms for users to connect, share experiences, and express opinions. However, the open and real time nature of these platforms also exposes users to malicious activities, including hate speech and abusive content. This project aims to address the rising issue of hate speech on OSNs, acknowledging its potential offline consequences such as physical violence and riots. The prevalence of hate speech on social media poses a significant societal challenge. The impact extends beyond the digital realm, leading to real world consequences. As controversial content often garners high user engagement, it becomes crucial to develop effective methods for hate speech detection and mitigation. Current content moderation efforts are hindered by the sheer volume of user generated content, necessitating the implementation of advanced technologies for efficient and accurate identification of offensive content. So, the primary objective of this project is to enhance the detection of hate speech on online social networks. By leveraging advanced deep learning techniques, we aim to overcome the limitations of existing methods. Traditional approaches relying on handcrafted features and bag of words models often fall short in capturing the nuanced semantic relationships within textual content. So, this project explores the construction of multiple models, including CNN combined with bi-LSTM, BERT, DNN, CNN, LSTM, etc., for hate speech prediction. This diverse set of models offers a comprehensive understanding of the context in which offensive language occurs. And the beneficiaries of this project include social media users, online communities, and society at large. By effectively identifying and mitigating hate speech, the project aims to create a safer online environment, promoting positive interactions and reducing the risk of real world harm. Additionally, social media platforms stand to benefit by enhancing their content moderation capabilities, therefore, improving user experience and maintaining a reasonable online community. Object of the project. So, as I mentioned earlier, the primary objective of the project is to create an automated approach for identifying hate speech on online social networks, that is, OSNs, specifically addressing challenges in real time communication. The goal is to establish a robust model capable of efficiently detecting and categorizing hateful content. And the goal is to establish robust models including CNN combined with bi-LSTM, BERT, DNN, CNN, LSTM, bi-LSTM, and GRU, capable of efficiently detecting and categorizing hateful content. And the objective also involves deploying and assessing the effectiveness of multiple models on three benchmark datasets related to Twitter. We will conduct a comparative analysis against state of the art and baseline models, optimizing various factors such as word representation techniques, optimization algorithms, activation functions, and batch size to enhance overall performance. Requirements needed to execute this project are software requirements. Software needed is Anaconda. Primary language used is Python. Front end framework used is Flask. Backend framework used is Jupyter Notebook. Database used is SQLite 3. And front end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working models of law of work. So the first step is importing required packages. So the initial step involves importing essential Python libraries such as NumPy, Pandas, Matplotlib, TensorFlow, Keras, and NLTK. These packages are crucial for subsequent tasks, including data processing, visualization, and model development. The second step is exploring the dataset. So, this phase focuses on understanding the structure and contents of the hate speech data consisting of three datasets. This exploration serves as the foundation for subsequent data processing and analysis. The third step is visualization. Here, visualization techniques are applied to gain insights into the dataset structure, distribution, and potential patterns, laying the groundwork for informed data processing. The next step is data processing. So, data pre processing is crucial for refining the text data. This involves removing URLs and other unwanted characters, punctuation, stop words, and normalization of the text. These steps aim to clean and standardize the text for further analysis. The next step is tokenization. Tokenization involves breaking down the text into smaller units, such as words or subwords, for further analysis. This step is performed using different tokenization methods, including Keras tokenizer and BERT tokenizer, catering to various model requirements. The next one is feature selection. In this step, relevant features are selected based on their significance for subsequent analysis. This step is crucial for optimizing model performance and reducing dimensionality. The next step is splitting the data to train and test. In this step, the dataset is split into training and testing sets to facilitate model training and evaluation. This ensures that the models are tested on independent data to assess their generalization performance. The next step is training and building the model. So, training involves building models such as CNN combined with BiLSTM combined with BiLSTM, CNN, BiLSTM, BERT, DNN, LSTM, and GRU, each serving a unique purpose for hate speech classification task. The goal is to explore diverse architectures and methodologies for optimal performance. And in the next step, as an extension to the project, hybrid models like LSTM combined with GRU and BiLSTM combined with BiGRU are also explored. This step aims to create robust models capable of accurately predicting outcomes. And as an extension again, a Flask framework with SQLite is implemented for user authentication, allowing users to sign up and sign in, providing a secure and interactive environment. So after signing in, users input data. This undergoes pre-processing steps to prepare it for sentiment analysis and prediction. And the trained models are applied to predict outcomes based on user input, offering insights into sentiment analysis and tweet polarity. And in the next step, latent dirichlet allocation, that is LDA, is employed to identify underlying themes within the pre-processed tweet data, enhancing the project's understanding of user-generated content. And the final outcomes and analysis are presented through the front end, providing users with a user friendly interface for testing and analysis. Now we'll understand about the algorithms used. So, the first algorithm built is BERT, that is bidirectional encoder representations from transformers. So, BERT is a transformer based model designed for natural language understanding tasks. It employs attention mechanisms to capture contextual relationships between words bidirectionally, leading to state of the art performance in various NLP tasks. BERT excels in understanding the nuances of language and context, making it suitable for hate speech detection. The next algorithm built is DNN, that is Deep Neural Network. So, DNNs consist of multiple layers of interconnected nodes, each layer learning progressively more complex representations. They are versatile and applicable to various tasks, including classification. In this project, a DNN is employed for its ability to capture intricate patterns in hate speech data. The next one is LSTM, that is long short term memory. So, LSTMs are a type of recurrent neural networks designed to overcome the vanishing gradient problem, allowing them to capture long term dependencies in sequential data. They are well suited for understanding context and relationships within textual content. The next algorithm built is CNN, that is convolutional neural network. So, in the context of text, CNNs use convolutional layers to capture local patterns and features within the input. While traditionally applied to image data, CNNs adapted to NLP tasks, proving effective in detecting patterns and representations in sequential data. The next algorithm built is BiLSTM, that is bidirectional long short term memory. So similar to LSTM but with the added capability of processing input sequences in both forward and backward directions. This bidirectional processing helps capture contextual information effectively, making it suitable for NLP tasks like hate speech detection. The next algorithm built is combination of CNN with two bi-LSTMs. So the hybrid model comprising a convolutional neural network followed by two bidirectional long short-term memory layers synergizes the strengths of both architectures for improved hate speech detection. The CNN extracts local features while the subsequent bi-LSTM layers capture long-range dependencies and contextual information, resulting in a comprehensive model that excels in understanding both the intricate patterns and sequential context within textual data. This amalgamation aims to enhance performance by effectively combining feature extraction and contextual understanding in a single, robust architecture. And the last algorithm built is GRU, that is gated recurrent unit. So GRUs are another type of RNN designed to address the vanishing gradient problem. They have a simpler architecture compared to LSTMs but are effective in capturing dependencies in sequential data. GRUs are computationally efficient and are used when balancing performance and complexity is essential. Now we see the comparison graphs of the algorithms built on dataset 1 belonging to hate speech. So this is the horizontal bar graph comparing accuracy scores of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis I have F1 scores and on y-axis I have algorithm names. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for classifications. So these are the comparison graphs of the algorithms built on dataset 2 related to hate speech, and these are the comparison graphs of the algorithms built on dataset 3. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code file. So in these folders, I have the required datasets on which we will train the models. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And these are all model files which contain algorithm information. These files will be loaded into the project code during runtime to utilize the trained models. And these are Jupyter source files which contains combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is topic modeling Python main code file, and this is the signup.db file. This file is the database file used to store user information. So now copy the path of the code folder from the address bar of the file Explorer. I'm copying it. Open Anaconda prompt. So now use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if we are new users, we have to register first. Fill in all these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide a credentials, username and password and click on login button. So it has redirected us to the classification page. So here we can see a classification link, click on it. So as I mentioned earlier, we can perform the project using three different datasets, dataset 1, dataset 2 and dataset 3. So first we'll execute the project using dataset 1. Click on it. So here we can see a enter your message box where we have to enter any message and the application will classify it as either hate or non-hate speech. So I have entered this message. Now click on predict button. It will take some time to load. So this is the entered message and here we can see the classification, that is the speech is hate. And here we can see the topic for the paragraph is most dependent upon these words. So dependent upon these words, the application has classified this message as hate. Now click on classification link, click on dataset 1 link. We'll try giving another message. I have entered this message. Now click on predict button. This is the entered message and here we can see the classification, that is the speech is non-hate. And here we can see the words dependent upon which the application has classified this message as non-hate. Now we'll execute the project using dataset 2. Click on classification link, click on dataset 2 link. So here we have to enter any message. So I have entered this message. Now click on predict button. This is the given message and here we can see the label, that is the speech is non-hate. And dependent upon these words, the application has classified this message as non-hate. We'll try again. Click on classification link, click on dataset 2 link. This is the entered message. Click on predict button. So for this entered message, the classification is the speech is hate. And dependent upon these words, the application has classified this message as hate. Now we'll execute the project using dataset 3. Click on classification link, click on dataset 3 link. I have entered this message. Now click on predict button. This is the entered message and here we can see the label, that is the speech is hate. And dependent upon these words, the application has classified this message as hate. Click on classification link, click on dataset 3 link. We'll try again. I have entered this message. Now click on predict button. This is the given message and here we can see the classification, that is the speech is offensive. And dependent upon these words, the application has classified this message as offensive. So similarly, we can enter any message and can get the classifications. Click on classification link, click on dataset tree link, enter the message here, enter the message and click on predict button. This is the entered message, and here we can see the classification, that is the speech is neither hate nor offensive. And dependent upon these fields, the application has classified this message as neither. Now click on sign out. So the conclusion here is the project achieved automated identification of hate speech on online social networks, effectively addressing real-time challenges through the implementation of robust models for efficient detection. Diverse models such as CNN combined with two bi-LSTMs, BERT, DNN, CNN, LSTM, bi-LSTM and GRU were deployed and evaluated using Twitter datasets. This demonstrated the project's versatility in effectively addressing various forms of hateful content. And the integration of extension models added layers of sophistication to the hate speech detection system, contributing to improved accuracy and adaptability in handling nuanced forms of offensive language. The seamless integration with Flask ensures user friendly deployment, making the solution easily accessible for real world applications on online platforms, thereby enhancing the practicality of the developed system. So, in conclusion, the project significantly contributes to fostering a safer online environment by efficiently detecting and categorizing hate speech. This proactive approach promotes positive interactions and mitigates the risk of real world harm stemming from the online toxicity.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.